Well, we've made it this far. We might as well keep going, right? We're at lesson 26, and lesson 26 is all about how alternating series converge. This is the first lesson in our discussion on infinite series where we are okay with some of the terms being negative, as long as every other term is negative, and that's sort of how we're going to set up the discussion for today. We're going to talk about the alternating series test, which is a very unimaginative name for the test for convergence of alternating series. It's an alternating series. And you can always tell that a series is going to alternate because it's got -1 to some power, usually the n plus 1th power, so that when n is 1, this is 2, and the whole thing here turns out to be 1. It lets us start out with something positive. -1 to a power times a sub n. So what does that mean? That's a1 minus a2 plus a3 minus a4, and so on. An alternating series of this form converges if all of the following are satisfied. The a sub n's are all positive. A sub n plus 1 is less than a sub n eventually. And the a sub n's go to 0. The a sub n's all have to be positive. A sub n plus 1 has to be less than a sub n eventually, after some point. Maybe it's not true for the first 100,000 terms, but after that, the terms progressively get smaller and the terms approach 0. So what does this mean? Why is this here? This is here because the terms actually have to alternate. For it to be an alternating series, the terms have to alternate. If the a sub n's are not positive, then this doesn't really alternate. We want a positive number minus a positive number plus a positive number minus a positive number, and so on. What does this mean? This means that the terms have to get smaller. And this is the nice thing to stick on an index card, the terms have to get smaller eventually. Maybe not for the first 350,000 terms, but after that, the terms have to get smaller. And why is this here? Well, the terms have to approach 0. And that's just written there because I can't write in red and not write in red here. The terms have to alternate, the terms have to get smaller and closer to 0. Why? Well, let's look at the sequence of partial sums. Let's add terms. So here's 0, and then we add a1. a1 is maybe here. So then I want to look at the second partial sum. The second partial sum is a1 minus a2. Well, what does that do? A2 brings us back this way, but not this far, because A2 is less than A1. So we're not coming back this far. We're coming back maybe to here. Maybe I should call that S2. And then we add A3. So we're coming back this way, but not this far, because A3 is less than A2, so maybe we're here. And you can see what's going to happen, S4, S5, and what's happening. These are squeezing together like you're on The Price is Right. These are squeezing together. The terms are getting smaller. The terms are approaching 0. And so what happens if the terms don't approach 0? Well, then we can just bang back and forth between these two guys. We can just keep clanging around here like, well, we're never going anywhere. We want the terms to settle down. So we want the a sub n's to approach 0. And then you get the sum. The alternating series test works for precisely this reason, and all 3 of these pieces are necessary. The terms actually have to alternate, or else you can go way out there. The terms have to get smaller, or else S sub 2 could be out here somewhere. And the terms have to approach 0 or else you never settle down. Never settle down. Okay? So, time to play everybody's favorite game. Does it converge? This is the harmonic series, but we throw the alternation in. This is the harmonic series, 1, a half, a third, a fourth. But these make this positive, this negative, this positive, this negative, and so on. What happens to this series? Well, do the terms alternate? Yup. Do the terms get smaller? Yup. Do the terms approach 0? Yup. This series converges by the alternating series test. See how easy the test is? Terms alternate, terms get smaller, terms get closer to 0. This is a familiar series. This is a P series. It's a P series. 1 minus a fourth plus a ninth minus a 16th and so on. What happens to this series? Do the terms alternate? Do they get smaller? Do they approach 0? You tell me. Yes. Uh-huh. Sure do. This series converges by the alternating series test. Going one more, same theme. Right? I'll write out a few terms, sub in 1, sub in 2, sub in 3, sub in 4, and so on. And the question is, do the terms alternate? Do they get smaller? Do they get closer to 0? Think for a moment. Okay, do the terms alternate? You betcha, because this will always be positive and this guarantees the alternation. Do the terms get smaller? Not here they don't. But here they do and here they do. So this is a missing link. But I think we could take the derivative of this function. If we were to take the derivative of 4x over x squared plus 4, we would recognize that that derivative is negative for x is greater than a certain value. And so, yes, eventually the terms get smaller. And the terms do get closer and closer to 0. And so this series converges by the alternating series test. Okay? Okay. So, I mean, I could run a bunch of examples by you, but I don't really think I need to. You can test those yourself, and you're going to say, wow, 10 minutes? He's done in less than 10 minutes? And I'm going to say, yes. So, you're welcome. I'll see you soon.